Greetings, class, and welcome to Wednesday, April the 15th. In this video, I'm going to do some announcements and then we'll branch off into looking at some of the new material for this week. To begin with, though, I want to talk about the one thing that I'm sure everybody's has questions about, and that is test corrections. So, Exam 3 test corrections. I'm in the Exam 3 window right now, and you can see that I have a new file here called Exam 3 Test Corrections. It's an Excel worksheet, and then there is a new assignment here for test corrections. So here's what's going to happen. I will arrange it so that you'll be able to see your exam results in Canvas. Again, you won't need the webcam or any of that sort of thing to do that, or the lockdown browser. What you will be able to do is to go into your exam results, look at the problems that you got wrong, the questions you got wrong, and then calculate a response or a correction for those. So here is the Excel workbook that you will submit. It has each of the questions numbered 1 through 20 here, and a box underneath each one where you can type in a response. If you got the question wrong, if it's a concept question, you need to explain what was wrong about the concept that you, or what is the correct concept and why. And if it's a problem, you can show us or explain, show me or explain to me how you should have calculated your answer. So you will have these options. Now, not every one of these will require a response from you because, and also the reason I set it up this way is because everybody's test is different. So these questions will be different for everybody. However, when you go through here and you respond to these questions, you're responding to the questions identified as incorrect in your test results. So you go to the first one that you got wrong, you explain what needs to be corrected about that and why. If you had a calculation, you explain what was wrong with the calculation and what you need to do, how you need to calculate it, or you can just show the new calculation and say this is what the calculation should be. If it's a calculation problem, that's a little bit more straightforward. With a conceptual question, you're going to have to explain a little bit more about that. So these are just boxes for you to type in. When you type into it, you can uh, basically write a paragraph here if you need to, but you can also type in an example of a calculated formula if you want to use that. So that's the test corrections. Once you do this, you need to enter your name in the worksheet, and then when you go back here to exam 3 test corrections and click on this, you will submit the assignment, which will be a copy of the file that you use or the Excel worksheet that you use. Now, I do have one thing I need to make very clear. I cannot read numbers files created in Mac. If you're using a Mac and you create a file with the numbers, a document, if you use that document, what I need you to do is to do screenshots of the corrected questions. I cannot open those files. I had a couple submit for the extra credit. I couldn't open those either. So if you are using a Mac, make sure that you do some kind of alternative for this assignment. Also, if you are using a Mac, you can get Windows 365 or Office 365 as a student free through the Ball State website. So I would highly recommend that you do that and use Excel. It's much easier to do it that way than it is to do a screenshot. So test corrections, that's how we're going to do it. I will open this accessibility to the test up today. You will have until Friday at 11:59 p.m. to complete these corrections. So I hope that is helpful. I did finish the grading, and I know right now you can't see the grades, but I'll make those visible in a little bit. Uh, but I can say that if you do want to do the test corrections, fine. If you don't need to, if you're satisfied with your grade after you look at the test, you don't have to. This is an optional assignment, so you don't. If you are interested in improving the grade you got on the exam, go ahead and do the test corrections. If you are happy with where you're at, if you're okay with it, then you don't need to do anything at that point. So that's the test corrections. That was the big announcement that I wanted to make. But there are a couple of others. One is that we have a discussion for this week that's due on Friday. It's very similar to the discussions we've had the last 2 weeks. But again, just make sure that it's called Discussion for Week Ended 4/12. Make sure that you are participating in that. And then there's also an assignment due from Chapter 12, but it's not due until next week. So I want to go back to Chapter 12 to show you where that is. Um, I didn't put it in the module, but it is an assignment and it's out there and it's available to you now. So it's in McGraw-Hill Connect. Here it is, Chapter 12, Differential Analysis. It's due April 21st at 11:59 p.m. In fact, here is also the discussion that's due for this week as well. So those are the two things you need to be focused on, at least for this class. Um, and coming up, I'm going to do this discussion and illustration of what Chapter 13 material is about. But I'm also going to post a couple of demonstration problems in Chapter 13 module that you'll be able to look at in preparation for Friday. Because on Friday, we'll do more with the calculations than we will be doing today. So I just wanted to bring those things to you and let you know or keep you updated. Right now, I want to go over to this PowerPoint that I have waiting about capital budgeting decisions. And a couple of the things that we need to talk about with Chapter 13 really is how we evaluate our use of capital resources for a project. In other words, there's a proposed project that comes along, and we want to decide, okay, we have two projects presented in front of us. We need to decide which one is the best or which one we want to do. Many of these decisions are going to relate to things like this. Whether we do a plant expansion, we may be looking at two different pieces of equipment. We want to replace equipment. Do we want to lease or buy? Or what are our options there? Um, and by the way, whenever you go through a process like this, it's very good to use some of these tools to evaluate your options as far as the cost is concerned and as far as the ongoing return on those costs. So, what are we talking about? Well, we're going to have two levels of decision making. One is going to be a screening decision, which basically says there's a minimal requirement for a project to even be considered. So, does this project get above that screening process? And if it does, then we're going to move into the next area. We're going to think about, okay, which we're going to compare perhaps two different projects. There are two ways, well, not two ways, there are three ways that we're going to look at evaluating projects. The first one is a payback method, and that really is considered a cash flow method. The net present value is also a cash flow method, and the internal rate of return really is based on the operating income that's generated. So when we look at the kind of cash flows we have going out for a project or anything else, we see repairs and maintenance, whatever the initial investment is in the project or maybe the equipment, Are there incremental operating costs for this? And what kind of working capital are we devoting to it? So um, I've been a part of some of these decision making processes in the past. When I was at Blue Cross, they were deciding, okay, we had this enormous building at the corner of Michigan and Wacker in Chicago, and we were in a lease, and the lease was okay when we signed it, um, but the costs were going up for the lease, and so there was a lot of analysis going on. Would it be better for us in the long run to build our own building? And eventually, through some analysis and considering what they wanted to do, they did, or what the long term implications might be, they did construct their own building on Randolph Street in Chicago. So basically, this is what we're talking about. Now, when we look at cash inflows, things that we have to consider are what are the, obviously, the revenues we're going to generate from the project, and how much does this project reduce outgoes? In other words, the reduction of costs is considered a cash inflow. And then finally, when we get done with the project, so if we purchase a machine, if we get a machine, we want to operate for a number of years, and we need to consider at the end of that operating cycle, what is that salvage value going to be? Um, I don't know how I don't know what your experience is, but I've worked with several companies, and one of the places I worked for was trading out copiers, and they had previously purchased a copier outright, and then basically decided to lease a copier, which was going to be a little bit cheaper. So they had this old copier there, and the guy that came in from the copier place when they were negotiating the contract, they said, "What kind of salvage value does this machine have?" And he took a look at it, and it had been around for a long time. And he said, "Well, really, I'll be doing you a favor to take it off your hands because nobody's going to use these parts anymore." So, or any of the components. So basically, salvage value depends on what somebody's willing to pay you for basically the scrap metal in the thing. And that was what we got. So when you're looking at those kinds of things, that's also a cash inflow at the end of the project. One of the things that we need to consider, though, in our evaluation of projects is the time value of money. This is a very important concept in this chapter. In net present value is a very important way to evaluate a project, and probably one of the more widely used methods. There are simpler methods, other methods that are probably a little bit easier to use. But when we talk about the time value of money, what we mean is a dollar today is not worth the same amount that that dollar will be worth tomorrow, because if we have a dollar today, we can invest it and earn interest on it between now and tomorrow. And the idea is that amount of interest we can earn is a discount. So we need to think about that. And when we think about it with using a net present value, we're talking about a discounted cash flows approach. Okay, now we'll get into that more later, but that's just kind of an intro to what we're going to talk about. The first approach that I want to address is the payback method. And the payback method is a very straightforward, easy approach to use. Basically, what we're looking at in the payback method is how long does it take for us to recoup the money we invested in the project. So the project's going to generate revenue. Based on the annual revenue, how long does it take to recoup the money that we initially invest? So this is the formula for a payback calculation. We want the payback period to be the investment that we are required to make in the project divided by the annual net cash inflow. As an example, here is a calculation. The management at the Daily Grind wants to install an espresso bar in its restaurant that costs $140,000. has a 10-year life, and will generate an annual net cash inflow of $35,000. They require a payback period of 5 years or less on all investments. What is the payback period on this one? So let's do the calculation. We take the cost, the initial investment, 140,000, divided by the payback period, or divided by the annual cash net or annual net cash inflow, and we get a payback period of 4 years. According to the company's criteria, just based on the payback method, the management would invest in the espresso bar because the payback is less than 5 years. However, the payback method has some problems or shortcomings. One of the shortcomings is it ignores the time value of money. In other words, all the dollars in the calculation are considered to be at their full value. None of them are discounted. It also ignores any cash flows that come after the payback period. So, in other words, the espresso bar in that coffee shop is going to last 10 years, but we, using the payback method, we're only concerned with the first 4 until we recoup the initial investment. Having a shorter payback period may not be an indicator of a more desirable investment or a more desirable project. However, with this method, the strengths are really are in its simplicity. Okay, it's a very straightforward and simple method to use, and because of that, it works very well as a screening tool. It also can help you identify projects that recoup money quickly um, or investments. So those are the things that really are the strengths of it. We may have uneven cash flows. So in some cases we do. We don't always have a predictable even flow of cash. So if a project has cash flows that change from year to year, the payback formula that we used earlier won't really work. It assumes that every year we have a consistent flow of cash. So, for example, here they have a project requiring an initial investment of 4,000 and provides uneven net cash inflows in years 1 to 5 as shown. The investment would be fully recovered in year 4 if you look at these and add these up. There are a couple of, this is the way, by the way, the net present value method is the way that many people will evaluate, or many companies will evaluate a project. So when we talk about net present value, what we're talking about is the net present value of the project's cash inflows compared to the present value of its cash outflows, and that gives us a net present value. Now, for our use of this, we're going to have these assumptions. First of all cash flows other than the initial investment occur at the end of the period, and all cash flows generated by an investment project are immediately reinvested at a rate of return equal to the discount rate. So, with those things being said, let's take a look at this. Lester Company has been offered a 5-year contract to provide component parts for a large manufacturer, and these are the details of this data right here. We have the cost of the equipment, working capital, relining equipment, salvage value of the equipment, and annual cash revenue and costs here. At the end of 5 years, the working capital will be released and may be used elsewhere by Lester. Lester Company uses a discount rate of 11% should the contract be accepted. Well, in order for us to completely understand this, we're going to calculate the present value of a couple of different things. Well, first of all, look, we have this annual net cash inflow. This is not the present value of it, but this is the cash inflow that we have. So what we want to do is to look at a present value on these. So if we do that, we're going to use the percentage that we have and have a factor that we're going to look up. It's a present or future value factor. Now, let me explain. I'm going to go and explain what these present value, future values are. Some of you may have had this already, and if you have, that's great. If you haven't, I'm going to try to explain it as well as I can here. This is a present value of an annuity table, and these tables work like this. Across the top, you see the interest rate. Down the side, you see the number of periods that um, money is going to be tied up in the project. So we have, for example, in this present value of an annuity at 11%, how many years was that? Let me go back and look. Okay, 5 years. We have a present value of an annuity of $1 at 5 years at 11%. Well, here's where they get that factor. We go to this uh, present value, not future value. I apologize. Present value table. We look down the side here for 5 periods. The number of periods is 5, and go across the top to the 11% right here, and the number right here, 3.696. That is the present value factor of those cash flows. In other words, the present value of receiving all this cash every year, $80,000, is $80,000 times 3.696. That's what the actual present value of those cash flows are. Okay? So, well, this is actually the net cash inflow. But the same process will work if we're looking at any outflows as well. So let's go to the next slide. Here they're saying, okay, at 3 years, we have to reline the equipment, and it's going to cost $30,000. So it's going to be an 11% factor. So we go back to this table and to get the present value of $1. Now, this is an annuity, which means a series of payments. To get the present value of $1, we need to use a different table. Here is the present value of $1. So we're going to once again go to the 11% and go out 3 years, and here's the factor, 0.731. So when we go back to the calculation here, that's where they get that value. So the relining of the equipment, when we consider that cash outflow as a lump sum, we're not paying it now, but we will in the future. What is it worth now? Well, when we look at it, it's $21,930. That's the actual present value of that payment. The present value of the series of payments or cash that we receive, or the net cash inflow, is $295,680. Okay, and then we go down to consider these last two items. So what is the salvage value of the equipment? Well, they're telling us it's $5,000, but that salvage value will occur 5 years out. So we're going to, this is a one-time event. So we go back to this table and we look at the present value of $1 at 11% for 5 years. And when we do that, we have a present value factor of 0.593. So we use that to calculate the present value of the $5,000 in salvage value and the release of working capital at that time. So at 5 years, we will release $100,000 in working capital. Once we do these present future value calculations, well, these are all present value calculations. Once we do that, we will total these up to see whether we have a positive cash flow or a negative cash flow, or net, not cash flow, net present value. So when we add all of them up, we get a net present value of $76,015, and it has a positive net present value. Therefore, we would pursue the project. So this is chapter 13 through the net present value method. And what I'm going to do today is post the PowerPoint in chapter 13 section. I will also post these present value tables in that section as well. We will be referring to these as we go through some of the calculations in this chapter. Really, that's pretty much everything I wanted to talk about today. I just wanted to provide this video to get an introduction to chapter 13. And then again, we will go on with that next time.